All right, so I want to go back and review what we talked about in class today. And I broke this up. I broke the little chart up so you can kind of see what you're looking at. So first of all, remember that synthesis means I'm taking two things and I am adding them together, okay? So this is why if you look at both of these, you've got two things. And so if you're looking at the first one, okay, so like you've got silver and you've got oxygen. So if you're looking and you're putting together these two, silver has a charge of +1. Oxygen has a charge of -2. So this is going to be, remember we cross Ag2O. Now, you realize that this is not a balanced equation, so you could go in and you could, if you wanted to balance this, you could put a 2 here. That would give you your 2 oxygen on each side. And then you just could put a 4 here to give you your 4 Ag, and that would be a balanced equation. I'm not right now worried about you balancing them. I just want to make sure you can predict the products. All right, so then let's look at this one. So you've got CaO. This is calcium oxide. All right, so calcium is a metal. So right here, metal oxide with water forms a base. Bases always, like I told you today, end in OH. So put your metal, Ca, and then your base, OH. All right, here's where everybody is kind of getting confused. I can't leave this as CaOH because this has a charge of +2. This has a charge of -1. So to make this balanced, I have to write the correct formula. So it would be Ca parentheses OH2. So those are synthesis reactions. All right, decomposition means I am taking something and I'm breaking it down into different parts. So I've got potassium carbonate. All right, look for the word carbonate in your example. It comes right here, metal carbonates. So here's what I've got to do to predict the products. I'm going to put the metal, calcium is the metal. So I'm going to put a K. It forms a metal oxide, so that would be K2O. Once again, the way I'm getting this is a +1, this is a -2, okay? So you crisscross and you get your formula. And then the last thing I got to add is CO2. I get this from this right here. I'm not making it up. It comes out of using these general reactions, okay? Now, let's look at this one. If I look at lithium hydroxide, if you find the word hydroxide right here, okay, so I'm going to produce a metal oxide and water. So my metal is lithium, okay. Oxide means it has oxygen attached to it. Remember, this is a +1, this is a -2, which is why I've got the 2 there. And then write what you have left over, which is water. And I'm getting that from right there. Okay. The next one is a chlorate. Here's what a chlorate looks like, ClO3. So metal chlorates decompose into a metal chloride. So here's my metal. So SR has a charge of +2. Cl has a charge of -1. So it's SrCl2 plus oxygen gas. Once again, I'm getting that from right here, okay? So you've got to just put the formulas, use these general equations in order to predict the products. All right, let's look at a single replacement reaction. First of all, you know it's a single replacement when you've got this element hanging out by itself. So now look at what it's trying to combine with. It's trying to combine with water. So that means that it has to be following B. So we're going to look at the rule for B. If an active metal replaces the hydrogen for water, you're going to get a metal hydroxide. So remember, hydroxides end in OH. So lithium hydroxide, this is a +1, this is a -1. That's why I don't have to have subscripts. And then I'm going to get a hydrogen gas. All right. So right here, that's where that comes from. This is where this comes from. Okay. Single replacement, magnesium plus aluminum chloride. This is my lone metal. Here is the metal that it's attached to. So think of this as A, B, C. So I need to move, and I'm going to have AC, which is MgCl2. Remember, this is +2, this is -1. That's why I'm getting the formula. Plus B by itself, which is aluminum. Okay? So all I'm doing is following this formula. All right? Here's my A. Here's my B. Here's my C. So I've got AC. I'm sorry. Yeah, AC, and then I've got B out by itself. Okay? All right. Let's look at double replacement. Double replacement means that two things are going to swap. So copper is going to go here. Magnesium is going to go here. The problem is you've got to know how to make the formulas on the other side. Since copper, you know that sulfate is -2. Since there's no subscripts, this has to be +2. So Cu, and I'm changing that with nitrate. Nitrate is a -1. So that would be CuNO3 2 plus Mg is +2, which is, so when I combine it with the -2, I'm just going to get MgS. So you've got to use your oxidation numbers. All right. So my next one, I'm going to take lithium and put where magnesium is. And I'm going to put magnesium where lithium is. So lithium has a charge of +1. Sulfate has a charge of -2. So it's going to be LiSO4 plus magnesium hydroxide. Magnesium has a oxidation number of +2. And hydroxide has an oxidation of -1. So I need 2 of those to suffice. So that's how you do double replacement. And then finally is combustion. Guys, these are the easiest ones. The only thing you ever have to write down is right here. In a combustion reaction, you produce CO2 plus H2O. Anytime you see oxygen, anytime you see a hydrocarbon, you will always, always, always get CO2 and water.